Question 19. This question is about the construction of a modern bridge by just adding section by section to the existing bridge. So let's look at what the question is focusing on. The first part is the support cable which keeps section S in equilibrium is at an angle of 25 degrees to the horizontal. The existing part B of the bridge provides a horizontal force on S. So our focus is on the section S, and therefore now I will take away the irrelevant part. So I've isolated S from the earlier diagram. So I have to write the three forces acting on the bridge. There is a horizontal force which acts from the bridge onto section S. So I call this force F, and then the weight is W, right? So these three forces allows me to draw a vector diagram. So I will preserve the direction of each of these three vectors. The first one is the weight. I draw vertically down, that's W. And the second one, which is from the support cable, which provides the tension. So I draw it at 25 degrees to the horizontal upwards like this. So this is the tension, which is actually 25 degrees to the horizontal, right? And then the third force is the horizontal force. Okay. Third force is the horizontal force F, right? So alternate angles show that this is 25 degrees to the horizontal. So once you form this vector triangle, it means that it is a case of equilibrium, because when all three vectors are added together, you have a zero resultant because the vector diagram is a closed triangle. Now we'll move on to part B of the question. You are asked to determine the tension in the cable and the horizontal force which B exerts on S. So you want to find the tension T and the force F, right? So you use trigonometry for part B. So to find the tension, we use sine 25. Sine 25 is equals to the opposite divided by the hypotenuse, which is W divided by T. And that is how you are able to get the tension, which ends up as 7.1 times 10 to the power 5. And if you want to get the force F, you choose tangent 25 degrees. So F is made the subject of the equation, and you make the simple calculation, you'll be able to obtain F equals to 6.4 times 10 to the power 5 Newton. That's the end of the discussion.